Right now, one of the largest stars in the night sky may be approaching the end of its life, and when it finally explodes, it could briefly outshine an entire galaxy. The unsettling part is, astronomers still don't know when it happens. It could be tomorrow, it could be in 100,000 years, and as of 2025, a discovery made by NASA has made that timeline even harder to predict, something no living human has ever seen. This isn't a distant event with no relevance to life on Earth. A supernova hasn't been seen in our galaxy since the 17th century. Every human alive today, every astronomer, every physicist, every person who has ever looked up at the night sky has lived in a universe where no nearby star has exploded within visible range. Betelgeuse would change that. Human civilization has never witnessed a nearby supernova like this in modern history, and the night sky would never look the same again. The giant in Orion. Find Orion on any clear night. Look for the 3 stars forming the belt. Then look up and to the left, that reddish point of light, slightly orange, slightly dim compared to what it once was, is Betelgeuse. It is so massive that if placed at the center of our solar system, it would consume the inner planets completely, and its surface would extend beyond the orbit of Jupiter. It is a red supergiant, the classification given to the largest, most evolved, most unstable category of stars. They are not stars in their prime, they are stars in their final chapter, swollen to enormous size as their fuel runs low, burning through their remaining reserves in the final millions of years of a life that began tens of millions of years ago. Betelgeuse is roughly 650 light-years from Earth, close enough that when it explodes, the light will be visible in broad daylight, far enough that it poses no danger, and stars this large don't die quietly. And then the star changed. In late 2019, something happened to Betelgeuse that had never been observed before. It dimmed dramatically. The star dropped nearly 40% of its usual brightness, falling so far below its normal output that astronomers around the world took notice. Some began asking questions that hadn't been seriously asked before. Was this it? Is it possible we'd have another great dimming of Betelgeuse? And could it mean Betelgeuse would explode soon? For a moment, some astronomers thought this might be the beginning of the end. It wasn't. The explanation, confirmed later, was a massive eruption of dust from the star's surface, a cloud of ejected material that temporarily blocked its light from reaching Earth. Not a sign of imminent collapse, but it proved something important. Betelgeuse was becoming increasingly unstable. And then the star changed again, and this is where things become uncertain. When gravity finally wins, to understand why Betelgeuse will eventually explode, you need to understand what's been keeping it alive. For millions of years, a star like Betelgeuse has been held in balance by 2 opposing forces. Gravity pulls inward, trying to collapse the entire mass of the star into itself. Fusion pushes outward, the energy released by nuclear reactions in the core creating enough pressure to hold gravity back. Massive stars fuse simple elements like hydrogen to create more complex elements like helium, with energy as the byproduct. As they age, they run out of the simplest fuels and progressively burn heavier elements until nuclear burning ceases when the core is dominated by iron. Iron is the end of the road. It cannot be fused to release energy, and once that happens, the collapse becomes unavoidable. The moment an iron core forms, fusion stops producing outward pressure, and without that pressure, gravity wins. The core collapses in less than a second. The outer layers of the star, still falling inward, rebound off the collapsed core in a shockwave of incomprehensible violence. That explosion briefly reaches 10 billion times the sun's luminosity. For millions of years, fusion pushes outward. Eventually, gravity wins. The detail that changes everything. But this is where Betelgeuse becomes unpredictable, because astronomers still can't determine exactly how close it is to exploding. That's what makes Betelgeuse different from almost every other star we can observe. In July 2025, astronomers using the Alopeke instrument on the Gemini North telescope confirmed something long predicted but never proven. Betelgeuse has a companion star. NASA researchers announced they were able to pick out this companion star for the first time, combing through data from the Gemini North telescope and using a specially designed camera that cut through the bright glare emanating from Betelgeuse. The companion, now officially named Siwarha, is a low-mass star orbiting extremely close to the red supergiant, hidden for decades by Betelgeuse's overwhelming brightness. The discovery matters for one specific reason. Scientists now think that this companion star may have affected the dimming and brightening of the red supergiant, creating a degree of uncertainty about how soon it might explode. Every model built to predict Betelgeuse's timeline was built without accounting for a companion. Those models now need to be revised. The timeline scientists thought they had is no longer reliable. The star became harder to predict the moment astronomers realized it wasn't alone. What the sky would look like. When Betelgeuse finally goes, the first sign won't be visible at all. The first surefire signature would come in the form of high-energy neutrinos flooding detectors all over the world in a burst spanning some 10 to 15 seconds. Neutrinos escape the collapsing core immediately, passing through the star's outer layers as if they don't exist. Light takes hours longer to fight its way out. A global network of neutrino detectors called SNOOS, the Supernova Early Warning System, would send automatic alerts when this burst is detected. Every telescope on Earth would be pointed at Orion before the first visible flash arrived. And then the light would come. At peak brightness, Betelgeuse would shine approximately as brightly as 10 billion suns packed together. It would be visible during the day, brighter than any planet, almost as bright as the full moon, but concentrated to a single point of light, not spread across a disk. The night sky would transform overnight. During those first 3 months or so, Betelgeuse would be bright enough to see clearly during the day as well as the night. Only after the 4th month or so would it become a nighttime-only object. People across Earth would stop and look up. For the first time in modern human history, the death of a nearby star would unfold in real time above us. Close enough to watch, far enough to survive. The question almost everyone asks at this point is the obvious one. Is it dangerous? Despite its brightness, it poses no danger to Earth because the enormous distance weakens the radiation long before it reaches Earth. The radiation, the shockwave, the charged particles, all of it disperses across the enormous distance between Betelgeuse and Earth. What reaches us is spectacular. It is not lethal. Close enough to witness, far enough to survive. What gets left behind? After the explosion, Betelgeuse is gone, but something remains. The shockwave expands outward through the surrounding gas and dust, heating everything it contacts and causing it to glow. Over decades and centuries, this material forms a nebula, an expanding shell of luminous debris that will be visible through telescopes for centuries and perhaps millennia to come. At the center, depending on how much mass the core retained during collapse, either a neutron star or a black hole will remain. A neutron star is an object the size of a city but more massive than the sun, spinning hundreds of times per second, radiating enormous energy. If it becomes a black hole, the core will collapse beyond any visible boundary, hidden forever behind an event horizon. Regardless of what happens, a new object would remain where Betelgeuse once burned, something stranger and denser than anything that exists in our neighborhood of the galaxy right now. What this connects to? There is something else worth understanding about this explosion, something that changes how you think about it. Every heavy element in the universe was forged inside a star. Carbon, oxygen, calcium, iron. The iron in your blood was created in an explosion like this. When a massive star explodes as a supernova, it doesn't just destroy, it seeds. The shockwave compresses nearby gas clouds, triggering the formation of new stars. The material it ejects spreads through the interstellar medium, enriching the next generation of stellar systems with the elements needed for planets, for chemistry, for life. Betelgeuse's death is not an ending. It is the beginning of something else, material that will eventually become part of new worlds, new systems, perhaps new forms of complexity billions of years from now. Every atom in your body was once inside a star. When Betelgeuse explodes, it will complete that cycle for billions of tons of material that may one day become something unimaginable. The question nobody can answer. So when does it happen? It could be tomorrow. It could be in a few 100,000 years. Because it's 500 to 650 light years away, it could have gone off 100 years ago, and we won't find out for a while. It may already be dead. The companion star discovery of 2025 complicated the models. Instead of making the timeline clearer, it made the star even harder to understand. The great dimming of 2019 didn't provide the answer. The erratic pulsations continue, and the core, the only part of the star that would tell us exactly how close it is to the end, is invisible to every instrument we've built. And that uncertainty is what makes Betelgeuse so unsettling. Still burning. Every night that Orion is visible, Betelgeuse is there, that familiar reddish point of light in the shoulder of the hunter. Slightly variable, slightly unpredictable, slightly changed from what it was a decade ago. Astronomers are watching it with more instruments than ever before. Neutrino detectors are primed to send alerts the moment a burst is detected. Telescopes on every continent are ready to turn toward Orion within minutes of the first warning. The entire apparatus of modern astronomy is, in a quiet and ongoing way, prepared for the moment. But the star hasn't given the signal yet, at least, not one we've detected. Right now, Betelgeuse is still there, burning in the darkness, but somewhere inside that star, the countdown may have already begun. Do you think Betelgeuse will explode in our lifetime? Let me know in the comments. There are still stars, planets, and phenomena in the universe that we barely understand, and the deeper we look, the stranger everything becomes. Subscribe if you want to keep exploring.